to the host file system. So for each emulator we start inside, we can assign different ports. So for the first firmware is, well, we start 3 firmwares, right? I'll give you an example what they are. This is the first firmware, which has this SHA-256, and this is the actual firmware, where it comes from. And you can see this is a Netgear WG103. It's obsolete, there is no more firmware upgrades to it, so it's not very nice. But we emulate all of these 3 firmwares. So version 2037 will be on port 2080, 222 will be on 3080, and 2025 will be on port 4080. So let's go to 2080. We'll just use some bogus. It doesn't work, right? But if we do recreate, it says recreate OK, and this is the first sign that the recovery of the admin session is successful. And if we go back, you see that we are logged in. Okay, and this is running in the emulator. I don't have any devices. It's not some remote tunnel to some. Okay, and well, we can see that these are. You can see that, of course, there's no wireless radio because we didn't load the wireless kernel module for the device in the emulator and so on. But I mean, this kind of errors occur. As I said, failure analysis helps you see this. But we can look at the logs, and you see that started now March 31, and it's excuse me. You see that this is BusyBox particular version. Compiled in 2011, and you can see also the time zone, so you can basically know which is the development center, which did it, right? You know exactly. Sometimes you see Korean time for some Korean products and so on, so you basically know who is the guy or the development center or server which produced this particular thing. You'll see some errors and so on, but the idea is that you see that it was easy to get as admin. Then we can do the same for the other version. Here we are not logged in. If we do the same thing, we are logged in, and in the logs you'll see a different log because it's a different firmware, so it behaves differently, and you can also see that the timestamp of the BusyBox is different, so you can all see the different versions come with different binaries, but you can still identify them based on different fingerprints, strings, or log files. And just for the pictures to be complete, I'll just do this for the last thing. And you can see that it works flawlessly on all these 3 latest firmwares from. And I said this is obsolete product. It doesn't receive any firmware upgrade. So if you see this kind of a device in a network, you have a 100% hit that you're getting admin, and then you're getting command injection because it also has command injection with no updates, right? And this is actually the command injection I'll show you is a 0-day. This one is a not 0-day. It's 5 years old vulnerability, but it's still there, right? Because they didn't even bother to check on all their firmwares. They produce the firmware. I mean, and it's easy because you can just spawn many emulators. Yeah, so this was the first thing. And you see this is even older one. This is 2010, not even 2011, and so on. Okay, so let's see some other quick things. So we also redirect the 20, I mean, you can do whatever you want. I mean, I'm showing how we do this, but we also redirect the port 22 of the emulator, so we can log in into the firmware, into the QEMU container, right? And let's say in our case, we'll just try to So we are logging in now in the QEMU container. Should it work? Oh, yes. And we used the Debian precompiled images, and they come with, you can find all the details in the paper where we get them. But you see, it's in our case, it's a Debian MIPS based on 4KC Malta development board, but it can be different. So just to show you, the chroot command is working something like this. And basically now I'm root. You see that it's the busy box, exactly the one which you saw in the web interface. And you can basically run it as a normal firmware, but we run it automatically. I mean, this I'm giving you just a sense of how we do it, but all these are scripted. Everything is sent as an automation script. And now what I want to show is being on in the virtual machine of which runs the QEMU, because I mentioned that we are in this virtual machine. I can show you very quickly. Sorry about that. Because all these web application tools, they can crawl the web interface. If it contains hundreds of files, it will crawl all these hundreds of files and then execute all known fuzzing, XSS, command injection, and it can take hours just to perform, or, well, depends on how big is the web application and how fast the emulator is. It can take hours still to get everything. So just for the sake of short demo, I show you that the 0 day, which is in these files and is documented in our paper in the links. Basically, what I am doing is that I'm mentioning to the Arachne web scanner to scan just these URLs in the thing. It found automatically, but again, right? I'm showing you for the sake of shortness. It's there. I already created it, and if I run the, you see that I'm running the, let's say, Arachne. I'm running it on localhost. It's localhost because it's virtual machine, so the QEMU is inside virtual machine, so it's a localhost, and it's the same port 2080, which I showed you earlier, right? It's the 2080. It's still there. It's fine. It's timed out, but I can recreate again the admin session, right? And basically, what I'm asking is that I'm asking to perform XSS tests on the sitemap, on the limited sitemap which I showed you earlier on these files. And you can see that with something with, okay, I know what it is. Okay, so you see that there is already one cross-site scripting detected in this particular file, in board data 102 PHP, and it says it's MAC address. So you see it found basically in a matter of seconds, right? I mean, and if I just prepared already the thing. It said the MAC address field, right? And I'm just having the ready exploit. And you can see that some of these files are not even session protected, right? I mean, you need to log into the web interface, but some of these files are not protected. And if I do like that, I'm getting XSS. And then what else I can do is I can do, for example, what we actually do again automatically. We specify to the everything. So, no. I'm logging in again in QEMU to show that there is no command injection indication file, and when I run the Arachne, you'll see that it basically will detect again in a matter of seconds. And so what we usually do is we create, in your case it can be different, but we create a file which is command injection something, and the random number. You see there is nothing like here. And then what I'll do, I'll just run again Arachne on the same 2080, okay? I'll again limit the sitemap, but it can go for all the sitemap, for all the PHP files, or all the CGI files, and I ask it to check for OS command injection, or to test. And the thing will just run. Come on. Just 1 second. Okay, so basically it started doing the OS command injection. Sometimes you see that the tools are also getting stalled, so you have to kill, you have to, but if you do it automatically, you don't care, right? And you see that we have some files created in www and in temp as command injection firmware. So basically what this tool does, you can put in OS command injection module to touch a particular file and so on. And for this particular example, let's go to TMP. There is this command injection, there is no password file. I already prepared the exploit. I mean, it's easy to create. Once you get the report from the Arachne, and we'll run it. And then you see that update success, but we don't care. And then you see that there's etc password here from the device, just because the Arachne tool managed to show us where exactly is the vulnerability and so on. So this is just one example what happens like in automated manner and so on. I think I need to wrap up a little bit late. The slides which will be available, you have all these details of vulnerabilities. There's another, and it affects a great deal of devices, like listed here, all of these devices inside, let's say, this path. This is our, we are now on Ubuntu, right, x86. And if we check the var and the document root from this firmware, we have this bunch of files, PHPs, and then if we execute the particularly crafted exploit, which is in logging handler, and we do cat etc password, then we'll get the password back and some other data from the script, which is some JSON file for APIs. So yeah, you can see that both methods, they work, like they work the QEMU, the emulator, and all this is automated. I mean, it's nothing fancy about automating this. So just to conclude the summary of the results, we found command injection like high impact vulnerabilities, the command injection XSS, CSRF, by using references in our papers, which this work is based on our ACM's AHI-CCS 2006 papers, and our Unix Security 2014 papers. If you are interested in this, should give it a try, and a list of tools for you to try out, which basically we use in our research, and some online tools to find the devices online or to check your theories about various devices. And then three main takeaways which we want to emphasize, that the large-scale firmware analysis, as you can see, is necessary because there's a
lot of vulnerabilities, and it's necessary, especially with IoT hype, it's really necessary to analyze the firmware, not just the x86 and the malware and so on.
We also demonstrate that the scalable and dynamic analysis of firmware is feasible, and it yields really good results and can yield even better results with some effort, some engineering effort. And we also see, and at least we conclude personally, that many vendors do not perform proper or basic security testing and QA, because you can see that easily, just by running out-of-stock, non-commercial tools, very automated environments, can find easy, serious vulnerabilities, and we don't understand why they don't do this. I would like to acknowledge my colleagues and my professors, and a very important note is that your feedback is very important to me personally and also to Black Hat, I guess. I'm pretty sure about it. And yeah, please rate this talk after you receive the email.